Thank you so much. Hi, everybody. Bonjour et bienvenue à ma présentation. Did I do that right? Awesome. So my name is John Sundell. I'm a Swift developer, and I also run Swift by Sundell, which is a weekly blog and podcast about Swift development. And today I am super excited to be here to talk to you about system design and how I believe that it's become a little bit of a lost art in the iOS and Swift developer communities. We don't talk a lot about system design, but there's one thing we do love to talk about, and that is app architecture. And specifically, what is the best app architecture? What's the single best one that you will always be able to use, whichever project it is, big or small? What's the best one? So today, I am hoping to give my answer to this question. But it's a little bit of a hard question to answer. So before we dive into it, I think it's a good idea, just like with any complex problem, to kind of break it down a little bit. So instead of talking about what the best app architecture is, we're going to start to look at what even is app architecture to begin with. Because a lot of people have different ideas around the community about what architecture actually is. Some people, they think about primarily their design pattern that they use, like MVC or MVVM. And some people think more about the way they work, like test-driven development or functional programming. But architecture is not something that we as software developers invented. In fact, it's been around for ages. So before we even talk about that, I think we should talk about what even is architecture. So a lot of people, we need to go deeper. So a lot of people, when they think about architecture, they don't actually think about apps and software or RX Swift or whatever it might be. They think about buildings, like this one. The Burj Khalifa is the tallest building in the world. Or this one, Apple Park, the roundest building in the world. Or maybe something a little bit more local, like the fantastic Louvre Museum here in Paris. Now, all these three buildings, they have very, very different design, they have different purposes, and they're used for different things, but they all have very distinct architectures. So what is it that really makes an architecture good or special or useful? Well, I think it kind of comes down to three things, kind of independent of what you're trying to build. Well, first of all, an architecture needs to be functional. It needs to serve the purpose of what it's trying to do. You wouldn't want me to give a talk here today in like a super tiny space. You know, we need things to be functional for the way that they're going to be used for. But we also want things to look nice, and we want things to be elegant. And this is true for our source code as well. It might seem cosmetic at first, but we want to have nice things when we're working with them. We want them to be nice and nice to handle. But maybe most importantly, I think a good architecture needs to be robust. It needs to be able to stand the test of time. And even though the apps we write today, they might not be around for 1,000 years like buildings, but hopefully they can be around for more than 3 or 6 months before it's legacy code and we have to actually rewrite it. But when we're talking about architecture in the iOS community, it seems like everyone is talking completely about design patterns. And design patterns, you know, we're talking about MVC or MVVM or Viper. It seems like these design patterns, these are just more and more letters. It's like when in doubt, add more letters. Well, the big million-dollar question here today is a design pattern really equivalent to an architecture? Is a design pattern all you need to create a good, solid, robust, elegant architecture for an iOS app? Well, if we think about it, buildings, they kind of have design patterns too. And this is the last time I'm using the building analogy, I promise. We have towers, we have offices, and we have museums. And I think that most people in this room don't work in an office that looks like Apple Park, but it's still an office. It still kind of conforms to the same design pattern. And I think that apps work the same way. We have design patterns, but it's a different thing from a complete architecture. And to kind of prove my point, if I were to ask every single person in this room, all of you sitting here, to please go ahead and build an MVC app, I am pretty sure that we would end up with a lot of different architectures, a lot of different systems, even though you were following the same design pattern. So why is that? Well, if we think about MVC in particular, all it really tells us is that in our app, we should have models, we should have views, and we should have controllers. And it defines some kind of rules around how those objects should interact with each other. But there's a lot of objects that are hard to place in one of these three buckets. For example, objects that we deal with almost every single day when we're working with app development, not only classes that we've built ourselves. For example, is UI application a model, a view, or a controller? You can kind of say that it's a view because it has the UIKit prefix and it's part of the view layer in a way. But it also has a lot of model stuff like, app version and things like that. And it's kind of a controller because it controls the lifecycle of the application. But there are trickier ones. Like how about things dealing with notifications? Like UN User Notification Center. It kind of is a controller for push notifications, but it also contains like registry for them. So it's kind of like model as well. The same thing with Notification Center as well. And here comes the most tricky one of them all, URL session. Is it a model? Kind of. It loads data. But some people would even call it like the networking layer. Does that mean that we're building an MVCN app? Not really, right? Well, it turns out we're not the only ones who have trouble categorizing these 4 objects. Apple, they have problem with that as well. And you know how I can tell? They are all singletons. And that way, we can use them from anywhere we want. We don't have to worry about architecture. Can access them for your model. Can access them from your view. It's free for all, right? So I think it turns out that design patterns are really great. They're great fundamentals to start with when designing a good system. But it's not a solution to a complete architecture. We need something else in between. And I would argue that that something else is system design. System design is basically a way to describe in our team where something new goes. Like when you create a new class, when you create a new type, a new file, where do you put it? What other objects should it talk to? What function should it call? And how should the API look like? Those are things that we need to work with when we work with system design. So today, I want to give you my top 3 practical tips on how to design robust, nice systems for iOS apps. And I want to keep it really practical because sometimes when we talk about architecture, it can kind of become very theoretical and not really anchored in reality. So I want to show you some really concrete examples here. And we're going to kick it off by talking about decomposition. Now, decomposition is basically a fancy way of saying breaking things up. So you probably heard about composition, putting things together. But before we can do that, we need to break things down. Because no one wants to work in an app that is just one big blob of code. No one wants to have to deal with something with just one massive thing. We want to break things up into smaller pieces. And ideally, we'd like to work, test, and even maybe deploy a single part of our code base in isolation. That will make it much, much faster to work on because we can do it more quickly and in a more modular way. So let's take a look at an example. And this kind of thing is like easier said than done because I think a lot of developers agree that breaking things up is a good thing, but it can be really tricky to do in practice. So let's say that we're building a new view, a new screen in our app. And let's say that we're building a podcast app and we wanted to be able to display a podcast. Now, most iOS developers, when you are faced with a problem like that, you go File, New, create new Swift file and subclass UI view controller, and let's create a podcast view controller. Now, there's nothing wrong with that. It's a very, very common approach. But if we think about it and we try to do some system design now a little bit ahead and try to look at what kind of parts of this view controller will we actually need to have. So let's just look at the UI for starters, and we will need to have a header, we will need to have a list of episodes, and at the bottom we have some actions. So we have 3 kind of distinct parts of this UI. But we also have a lot of things that this view controller will need to do in order to actually render these 3 parts. We need to do things like data loading and decode models. We need to have caching in place and extract data from those models to put them in the view. We need to handle taps on the cells and the buttons. So there's a lot of work that we need to do in order to render this UI. So this is where decomposition comes in. Rather than building one big massive view controller with all this logic baked inside one class, let's split things up a little bit. Let's start with the UI. We're going to split that up into 3 different parts. We have the header, we have the list, and we have actions. And in this case, we're going to use child view controllers to actually implement this. So we're going to have a header view controller, a list view controller, and an actions view controller. And this is a pattern that is becoming more and more popular in the iOS community, but it's actually been around since iOS 5. So it's really, really old, solid API that you can add one view controller to another, just like you do with your UI views. So now we have split things up. That's like step 1. But we can end up with a lot of code duplication because all of these view controllers probably need to perform similar tasks. So let's list those tasks. First, we have the header. It needs to load some data. It needs to decode that data. It needs to also do image loading. The list view controller is similar. It also needs to load data. It needs to also extract data, but it has a different action at the bottom there, handling cell taps. And then we have our actions view controller, which also is very similar, but there at the bottom, it needs to handle taps of the buttons. So we can see here that all these three view controllers, they have some differences of what they need to do, but they share a lot of functionality that they need to do. And this is a part where if we design a little system around this, we can actually end up with way less code duplication and a nicer architecture. So let's do just that. Let's take those 4 common tasks that we need to perform and actually design a little system. So what we're going to do here is we're going to split things up into 4 different parts. We're going to have our data loading performed by a networking service. We're going to have caching performed by a caching service. And these 2 are going to be system-wide services. They're not domain-specific. They're not specific to handling podcasts. You can use them throughout the app. But then we need some specific things for podcasts in particular. So we're going to need some model decoding in a podcast loader. And in this case, we use a view model abstraction so that we can have a layer between our core data model and our view. And this is domain-specific classes. So here we have specialized our more generic stuff to be more domain-specific. So what we've essentially done here is we've taken this massive podcast view controller, which if we just started coding day 1 after we got this design, it would probably end up having 1,000+ lines of code. And instead, we've designed a more decoupled and decomposed system around it with services, with specialized classes, and with composable UI components as well. But the cool thing is that if we start doing this for per feature, per view, we can actually end up with another level of decomposition as well. So not only can we have this relationship here within one feature, we can actually do it between feature. We can move all of this code into a framework called Podcast Kit. And we can do the same thing for other features as well, like a login kit, analytics kit, and so on and so forth. And that way, we can also decompose our entire app into separate pieces, which really makes them a lot easier to handle. So, decomposition, it is a way to separate each task that we need to perform, so that they can be maintained and tested in isolation. And child view controllers, services, view models, logic controllers, there's a lot of different tools you can use. They're all really great in order to actually split up these big, massive view controllers that we have. And finally, what we've done today here is just visualize all of this stuff before we started coding. And that can really save us a lot of time. Because sometimes, as developers, we get a design, we get eager to implement it, and we end up with kind of a little bit messy code or very, very big classes because we didn't really think ahead. So if we visualize a little bit more, things will get a lot nicer. So that is decomposition. Next up, let's talk about locks and keys. Now, when you hear this, you might think that I'm going to talk about encryption, but I'm not. Instead, I'm going to talk about managing dependencies. That might seem a little bit strange. What does that have to do with locks and keys? Well, let me show you. I am sure that a lot of people in this room, you have seen a guard statement or an if statement in your app that looks something like this. You have some form of state. In this case, it's a user, and it's contained by a user manager. So you have a shared user manager singleton. You unwrap it, but if there is no user, you kind of don't know what to do, so you just throw an assertion, right? So this here is kind of a little bit awkward if you have it in a context where you need a user. So in this case here, we're showing the friends list, so we can't really do that without a user. So this is it's a bit awkward, isn't it? We don't really know what to do. And writing this assertion failure feels kind of pointless because we kind of know or assume that this code will never actually be run. So even if we kind of do our homework and we make this a dependency injected proper dependency, so we have a user manager property and we then use that instead of a singleton, we still have this problem. So how can we solve this using locks and keys? What we're going to do is we're going to design a system where part of our system is hidden behind a lock. And this lock here is going to be that it requires a user in order to open it. So the user model becomes the key that opens the lock. What that means is that we can structure our code base into two distinct parts. We can have one part where we are guaranteed that we don't have a user, because the user hasn't logged in yet, for example. But in the other part of the code base, once we're past the lock, a user always exists. That means that we don't need to have those optionals anymore. We don't need to have those awkward guard statements. We can always use the user as a non-optional property. So that means that we implement classes like a user manager or friends list or inbox or something relating to the user. We are sure that we have a user. So how can we do this in practice? In this case, I'm going to use the factory pattern. Now, factory pattern is a great tool in order to create objects that essentially only creates other objects and to set up your dependencies that way. So we're going to start here with a root factory. This root factory is able to create all objects that don't have any specific dependencies. So here we can make our image loader, which doesn't really require a user. We can also make the login controller that we can use to log into the app. But more interestingly, we can make other factories. So we can actually ask the root factory to make a user-bound factory, which is bound for a specific user. And here comes the lock. So in order to call this method, we need actually to have a user. And we can get that through the login controller. So the login controller gets the root factory injected into itself, and then when it has performed login, then it actually calls this method. It retrieves a new factory, in this case is a user-bound one, and that way it can keep making new objects that actually have the user as a non-optional property, which is bound to that specific user. So it becomes a lot clearer. And the cool thing is that we can continue doing this in multiple levels. So just like we had the root factory create a user-bound factory, that factory can keep creating other things as well. It can create home view controller or inbox controller, and those things can keep making their own controllers and their own dependencies as well. And that way we can get rid of a lot of optionals that are not really optionals. So, locks and keys, the whole idea is that an object shouldn't really be created until all of its required dependencies are available. And by using a required object or a model as the key to open that lock, we can end up with a lot more predictable system design. We can have objects that actually can rely on the data that they need. And factories can be a great abstraction. There are lots of other great abstractions as well. Factories is one way to do it. And that way we can make sure that we need to pass the object we need before that object is created. So that is locks and keys. Finally, I want to talk about abstractions. Now, abstractions is something we deal with every single day. We have different abstractions in UI kit. We can go down to core animation. We have abstractions in our own code as well. So what is really the point of abstractions to begin with? Well, sometimes when we're building apps, we can feel kind of like we're going in circles. It can feel like this is all very familiar because we've seen it so many times before. It feels like kind of we've written the same code 1,000 times before and we keep doing it over and over again. And one thing in particular, I think every person in this room has probably written tens, if not hundreds of times, is table views and lists, right? You have so many different lists in your app, like you might have a message list or friends list or comments list or whatever list it might be. And they all need to conform to the same UI table view data source, the same UI table view delegate, and you kind of know the methods by heart, right? Number of sections in table view. Yes, I got it. So how can we create some abstractions to help ourselves kind of move faster and to share more code within our app? Well, I want to bring up two tools that I like to use to create my own custom abstractions. And the first one is generics. Generics is something we deal with all the time in Swift. We have arrays, we have dictionaries and sets and all different kind of generic types. But creating our own generic types is actually really easy and can be really powerful. So in this case, what I'm going to do is that I'm going to create a list view controller that can just be a list for any model. I can also do the same thing if I want to create abstractions on a more like lower level with, for example, data sources. I can have a generic list data source that is specific for my app that implements kind of all that boilerplate, but in a common way. You can do the same thing for delegates as well. Here I'm just creating a list action handler, which actually acts as a table view delegate. So this is something that you might have heard about before, or you might have used a base class before to achieve the same thing. But using generics in this way can be really, really nice and really powerful for a good reason. And that is that you can use a generic implementation that covers all of the boilerplate, all of the common use cases, but you can have concrete specializations. So what that means is that if you compare it to a base class, where you would need to put all of the functionality to handle all of the cases in the same class, which will probably be a massive view controller, let's face it, we can instead specialize those as we need to. So in this case here, we can specialize it for messages, for comments, for settings, with custom data sources if that's what we need. And that way we have great flexibility, but we can still reuse a lot of the same code. On the other hand, we also have protocols. And protocols are a great way to prevent strong coupling in an app. Strong coupling is basically what happens when we have one class, let's call it class A in this case, and it has all of these other classes that is using it. And they're all pointing to this class using a concrete type. So they all rely specifically on class A. And this is something that is very common to happen, for example, for networking libraries, for analytics frameworks, for common utilities. You see them, you can search the project for one class, and you find it in 100 different files. Now, from a system design perspective, this is kind of a little bit like painting ourselves into a corner. Because if we ever want to remove class A or refactor it, or maybe change it for something different, it will be really, really hard. We end up with this really, really strong coupling and this strong dependency. So how can we solve this using protocols? Well, let's say that we wanted to create a user manager that talks to a database. So it talks to the database to get the user data. And this is the only use case right now in our app for this database. But as we add more, let's say we wanted to also add a manager for notes and maybe one for movies, if we have a movie app, we start to have these multiple references to the same database. And what I like to do is follow the rule of threes, where if I have 3 references to the same concrete type, I think it's time to abstract that into a protocol. So in this case, I'm going to create a database protocol that uses the same API, but instead hidden behind that protocol. What that means is it opens up a lot of possibilities, both now and in the future. My app right now might be using core data, so it might be calling that under the hood. But I might also want to do unit testing, and for that, I can actually mock this protocol and have a mock database for my tests. But really powerful is that I am no longer bound to core data as a specific implementation. I can move to new databases, for example, Realm, very easily. I can also implement other implementations like an in-memory database for debugging or something like that. So it becomes a lot more flexible just by doing this little thing. So custom abstractions can be really, really great. It can be a great tool to create boundaries between various parts of a system, which each gives it a concrete, special area of responsibility. And generics and protocols are really like the bread and butter for creating abstractions. They can reduce duplication and enable us to be way more flexible. And I think it's perfectly fine to be inspired by other architectures, other techniques, other platforms and design patterns, as long as we try to stay consistent. Because no one wants to end up with like a Frankenstein monster of different tools and techniques, so we have to pick and choose which one we want to use. But as long as we do that and stay consistent, we can kind of use whatever abstractions we really want and whatever fit our use case. So, to go back to our original question, what is really the best app architecture? Well, if you ask me, I think that the best app architecture is an architecture that was decomposed into separate focused components that can be reused and maintained with ease, that it manages its dependencies using locks and keys to restrict global access and to really remove all these really awkward non-optional optionals. An architecture that uses abstractions to decouple all of its subsystems so that you can avoid repetitive code and you can have it in a more consistent manner. But maybe most importantly is that I think the best architecture is the one that you've created to fit your project by combining standard patterns that people know about and techniques with a custom system design. So I hope that this talk has inspired you to go back to your apps and do just that. And hopefully more people in the community can rediscover the lost art of system design. Thank you very much.
Thank you, John.
And I'll be around whole day today. I'll be around whole day tomorrow. Please don't hesitate to ask me a question. I would love to talk to you. I would love to hear about what you're working on. And you can find me online. I'm at John Sundell on Twitter. I have my website at Swift by Sundell. I'm also on the Stacktrace podcast, and I have some open source on GitHub.
Yeah, what a show, man! Like, do you sometimes lose your voice after the talks?
Every single time, after every single conference, I lose my voice.
We have some
I always carry a big box of
tea and honey.
Of tea and honey, yeah, of course.
Yeah.
And also a portable, water boiler, yeah, of course. No, but I carry like, pills for the throat, just to make sure I don't lose my voice.
Do you mind if I sit like a bit further because I'm hearing, I'm losing my hero.
Sorry about that.
That's right. Super interesting, super energetic. I mean, awesome.
As usual, yeah.
Yeah.
Thanks, guys.
So you told us what the basics for a good architecture, but will there such thing as a legacy architecture?
What do you mean by legacy architecture? Like an architecture you shouldn't use anymore?
Yeah, absolutely.
I'm not so sure. I don't think so, because I think that like a really good architecture is tailored for the use case, and if you have an architecture that you've been using for a long time, you might consider it legacy or it's not cool anymore, right? It's like it's old school, it's boring. That might actually have some really good benefits as well, where people know about it, it's easier to onboard people, and things like that. And even though it might have some flaws, it can have benefits as well, while more kind of modern design patterns and architectures and patterns might have the benefit of being more correct or less error prone, but they might also have a harder time for people to get into. So I think you need to kind of nail a good balance between those two things.
Yeah, and when it's time to actually move to something more modern or more like decoupled, do you have some tricks to kind of transform a legacy code to something that is more architectured with a more decoupling and locks and things like that? How do you try to implement that in a real application?
Yeah, that's a great question. So what I like to do is, with the team that I'm working with, I want to define what I call a North Star, which is essentially, in a dream world, if we could rewrite this application today, how would we architect it? What would be the ideal architecture, the ideal system design for this application? Then the next step is not file, new project in Xcode, delete all your code and start over, which is very tempting, but I've never done that, and I don't think usually it's a good idea. I think instead, follow the North Star. Just like if you were on a ship at the ocean, you would follow the North Star to guide you, right? But it doesn't mean you can teleport there. You need to kind of work your way there piece by piece. So defining like that North Star, that goal that you're aiming towards, that enables you every single time you implement a new feature to move closer towards that goal.
And what if this North Star moves? Like
it does, definitely. It should, right? I mean, maybe the North Star doesn't move in the sky, but, this analogy is breaking down, I guess. But you have to update it. You have to maintain like a living thing, because the product probably changes, the requirement changes, you might have more people on the team, you might launch in new markets. So you need to constantly revise and update your desired architecture. And it can be frustrating sometimes where you have this North Star, this ideal world, and then you have to work in the real world. But I think like always moving towards that really helps us stay focused on the task at hand.
Yeah, and something that sometimes is quite hard, like in my team we have this problem sometimes, is you have like some design patterns, some architectures that you like, that you want to kind of impose or have as a guide. But how do you share this idea? How do you share the good patterns that needs to be used and the things that needs to be removed and forgot? How do you share this knowledge inside the team?
I think it's super important that everyone kind of buys into the plan, buys into the North Star, to the system design, to the architecture. And that is really, the only way you can really do that is just talk to people. Like, when people join the team, sit down with them, draw up on the whiteboard. I always say that I think that a good sign of an architecture is when you can actually draw it on the whiteboard within like 10 minutes. So it doesn't require you to read the whole code base. You can just draw it up, show someone, and that way, either they might have new ideas, and this is also something I try to do when someone new joins my team, is I want to use the fact that they haven't seen this code before. So I don't want to only show them, oh, here's how we do things, but rather, what do you think? What are your ideas? Do you have, does this make sense to you?
The virgin
yeah, exactly. Mind. Like the blank eye is a really, really valuable thing for getting feedback. But then really just making sure that the team is on board. I am not a big believer in these like architect roles that like, or no, one person who decides the architecture, because then you have one person who likes it and the rest of the people disagree with it. It's better to bring people in and work together on defining an architecture.
We actually tried an idea a few months ago in my team, is creating small slots, small meetings every week, and every week we try to discuss about architecture, and we did that in a form of RFC, like request for comments.
That's awesome.
And try every time we have like a ticket, like really a backlog ticket that is kind of heavy, we'll try to have this discussion and put someone in charge and say, okay, you're going to write the RFC, like you're going to think about how you're going to architecture that and what kind of pattern are you going to use, what alternative did you use, and the same way like they do in maybe Swift Evolution mailing list, and that kind seems to be working quite well.
Yeah, that's awesome. I like that because it's a very lightweight thing. Like you wouldn't want it to be like a 2-hour meeting. Like you don't want it to be heavyweight. You don't want it to feel like a burden or like a chore.
Exactly.
You want it to be fun, and you want it to be something you can use to just discuss like where we're going. So I like that idea. Like I might steal that for my next team.
When is too much? I mean, you talked about decoupling, about decomposing. When it's too much? I mean, when do I have too many frameworks, too many protocols in my app, in your opinion?
Yeah, so I think that...
Is there a thumb rule or...
I think that it's like, so you have the both extremes, right? If you have a monolith
Absolutely.
where you have like one huge app, it's really hard to reason about. If you have every single class be its own framework, its own module, it's also really hard to reason about. So I think you need to kind of draw the line of where does this become easy to reason about, right? Like, like take a dish, for example. When you prepare a dish, you're putting the ingredients in and you have a dish and it looks nice. But you wouldn't want to eat like 10 dishes merged together in one big blob, right? Just put it in the mixer and drink it, right? No, that's not nice, right? So I think the same thing is true for code. Like you want these building blocks that you can use and reuse, but you don't want them to be so small that they become just too separated and hard to deal with. Okay. So I think that it's like the boring answer, it depends, but I think it depends on more like looking at it and be like, okay, how would I like to work with this, and what parts do I think I could reuse, what parts do I think could be specialized? Because that's another thing, like overgeneralization. Like that's why absolutely. I took the generic example of like the list view controller is a concrete type, right? It's like it does lists, that's all it does. And then you can have specializations of that so that you don't end up overgeneralizing.
Okay.
And there's a question that you probably didn't fully answered in your talk, is the network code. Like, where do you put that? Like, really practical way. Like, do you split that in?
So what I will have some kind of class dealing with networking, and usually I will do it on multiple levels. Just like I had the factory, so you had a root factory and a user-bound factory, I could have a root networking client or a root network manager and a user-bound network manager. Because sometimes you need like a user token to perform certain requests, and then you have the same awkward optionals, right? If let token, otherwise like assertion failure, oh, we didn't have a token. So that way I like to use multiple layers of networking as well with different models that I need. For example, let's say the podcast example again, you might need to do like podcast networking in there that requires the podcast to actually do like the podcast model. I would probably have like a podcast bound network client that actually does all that networking.
Okay. Yeah, still decoupling and
but still reusing the core, like the actual HTTP, like URL session, all that stuff, right? Or if you use a library for that.
Okay,
awesome.
Just one last question, like what's your favorite piece of architecture in Paris?
It must be the Louvre, right? That's why I used it in the slides. It's so beautiful. And every time I come here, I've been here like 4 or 5 times now. I go there, I take a new picture. So I'm going to have like, when I'm like 50, 60 years old, I'm going to have the Louvre over several decades. And it probably is going to look almost the same, but it's still going to be beautiful. Yeah.
Okay. Thank you very much, John.
Thank you so much for having me.